In this lesson, I'll show you how to solve differential equations with conditions. This is question number 1. The question reads, solve the equation 2y bracket 1 plus x to the power of 2 times y prime plus x bracket 1 plus y to the power of 2 is equal to 0, subject to the conditions y is equal to 2 and x is equal to 0. Just as before, when it comes to solving differential equations, you want to change all instances of y prime into dy over dx. So I'm going to replace this with dy over dx. I have 2y bracket 1 plus x squared dy over dx plus x bracket 1 plus y squared is equal to 0. Currently, we have two terms. We have this term and we have this term. What we want to do is make these terms exclusively to one letter. So as you can tell, this term right now has the letters y and x, and this term has the letters x and y as well. So what we want to do is change this equation in such a way where we have terms that are exclusively dedicated to one variable. So how do we do that? Well, it's going to require a little bit of thinking. So what I figured I would do is divide everything by 1 plus x to the power of 2. So divide this term by 1 plus x to the power of 2, this term and this term. So let's go ahead and do that, see what happens. 1 plus x to the power of 2. This will cancel out with this. And on this side, it stays the way it is, 1 plus x to the power of 2. And on the right side, where we have 0, it's still 0. Next, I'll divide both sides by 1 plus y to the power of 2. And look what happens if I do that. I have 1 plus y to the power of 2, it stays the way it is, and over here we'll cancel out with the expression at the top, 1 plus y to the power of 2, this cancels out with this, and on the right side it's still 0. So what we end up having by doing this is we have 2y dy over 1 plus y to the power of 2 dx, and in this term we have x over 1 plus x to the power of 2 is equal to 0. Now what we want to do is make the dx come here and the dy stay here. That way we can integrate both individually. So how will I get the dx to come here? Well, all I have to do is multiply both sides by dx. Look at this. If I multiply the left side by dx, I have to multiply each of these terms on the left side by dx. So this dx and this dx will cancel out, and over here it won't cancel out. So I'll have to write a dx here in the next step. And what I do to the left side, I have to do to the right side. So 0 times dx is 0 still. This gives me the expression, fully manipulated now, to look like this. 2y over 1 plus y to the power of 2, and I'll put the dy right here, plus x over 1 plus x squared dx is equal to 0. And just like I said at the beginning, this is exactly what I want, because now I'll integrate these with respect to their letter. I'll integrate this with respect to y and this one with respect to x. Let's see what happens if we do that. Now to integrate this function, you'll need to do a substitution. So I'll set u is equal to 1 plus y to the power of 2 and then derive implicitly with respect to y. And if I do that, I end up with du is equal to, this becomes 0 and this becomes 2y dy. So I'll replace this dy with du, and I will end up with 2y over u, which is what I set this as originally, and dy becomes du over 2y. Notice that I divided both sides by 2y and I ended up with dy. This will cancel out with this, leaving me with 1 over u, and that expression is easy to integrate. It's ln absolute of whatever u is, and we set u as 1 plus y squared. Now to find the integral of this term, I'll have to do the same technique, but we've already used u, so we have to use another letter. Let's use w. W is equal to 1 plus x squared. Taking the derivative with respect to x, we end up with dw is equal to 2x dx. I'm going to solve for dx by dividing both sides by 2x. This gives me dw over 2x is equal to dx. So I'm going to replace this dx with this expression. And I'll show my work here, and then I'll end up providing the completed product over here. I have the integral of x over what I set w as, and dx has become dw over 2x, where this x cancels out with this. I'll pull out the half, 1 over w. I can take the integral easily of 1 over w. It's actually ln absolute of 1 plus x squared, and this half goes at the front, is equal to c, our constant. Next, what I'll do to simplify this current expression is I'll drop the absolute value signs, since this and this can never be negative anyway. So there's really no point to leaving those absolutes. So let me show you what I mean. We end up with ln bracket 1 plus y to the power of 2 plus 1 over 2 ln 1 plus x to the power of 2 is equal to c. Furthermore, I'll multiply both sides by 2. That way I can get rid of this fraction, and then I can eventually use the rules of logarithms to combine these two terms. So multiplying everything here by 2, and of course this c by 2 gives me 2c on the right side, and this becomes 2 ln 1 plus y to the power of 2 plus ln, this goes away, bracket 1 plus x squared. And now I can combine these since they're being added, and I can take this leading coefficient of 2 and place it as an exponent. That's one of the rules of logs. You can do that. You have ln 1 plus y to the power of 2 all squared. And since it's being added to this other ln, we can technically multiply this by this. So I'll just put it right beside it without writing that ln anymore, is equal to 2c. Now, what I can do to get rid of this ln is raise it to the base e. And I have to do that to both sides. So if I raise this to base e and this to base e, this ln and this e will go away. And I have 1 plus y squared to the power of 2, bracket 1 plus x squared is equal to e to the power of 2c. Now we can apply the boundaries that they gave us originally, which were y is equal to 2 when x is equal to 0. So I'll set y is equal to 2 and x is equal to 0 at this point. Setting y is equal to 2 gives me 1 plus 4 to the power of 2, which is 25. 25 times 1 plus 0 is 1. So 25 is equal to e to the power of 2c. Therefore, going back to what I had here, this part is equal to 25. So 1 plus y to the power of 2 raised to the power of 2, bracket 1 plus x to the power of 2 is equal to 25. And this is our solution to our question. There you have it. That is how to solve differential equations with conditions. Make sure to watch question 2 for another example.